All right, I don't know how to hide the graph of the function there without removing the Cartesian plane as well, and I definitely don't want to remove that because we're gonna need it to graph something. But let's imagine it's not there for a minute and try to sketch the graph of this function using calculus. So let's see. Let's look at the first derivative. Let's figure out where this function is increasing and where is it decreasing. So the first derivative is 3x squared minus 12x plus 9. And the first derivative can change sign, meaning that the original function can change from increasing to decreasing or vice versa at the zeros or discontinuities. This is a polynomial, so it's going to be continuous everywhere. We just need to check for the zeros. Everything has a 3 in it, so we can factor it out and divide. And this quadratic factors nicely, x minus 1, x minus 3. Okay, so let's see what the function is doing. There's the first derivative, there's the function, and interesting things might happen when x is equal to 1 and when x is equal to 3. So we need some test points. Let's plug in 0, that's easy, 2, and let's say 4. So I'm going to plug these values into the derivative and see whether or not it's positive or negative. That's going to tell me if my original function is increasing or decreasing. When we plug 0 into our derivative, f at 0 returns just a 9. So that's positive. Our original function is increasing over that interval. When we plug 2 into our derivative, we get minus 3. It's less than 0, so it's negative. So our function is decreasing. And when we plug in 4, we get 9. That's positive. So the slopes of our secant lines, or rather the slopes of our tangent lines are sloped upwards. So our function is positive there. All right, now because these are zeros of our derivative and they're in the domain of the function, then that means we've got a hilltop right there, right? A 0 derivative means a horizontal tangent line. And we've got a valley right there at x is equal to 3. So we have identified local extrema. We know where maximums and minimums occur. And we can give ourselves those values by plugging them into the original function. Let's see. The value of the function at this point, f at 1, if you plug 1 into your function, you get a 5. The value of the function at this point, f at 3, returns a 1. So we just showed ourselves that we increase up until we hit 5, and then we decrease until we hit 1. And then on the right side of 3, we increase, right? Our minimum was at 3. This maximum was at 1. So let's see that in the graph. We increase until we hit the first critical number at 1. We see we have a horizontal tangent line right there, and the maximum occurs at 5, just like we thought it would. We then decrease between 1 and 3, just like we thought it would. And we have a minimum at 3, and it returns a value of 1. We already knew that. It then increases on the right side of 3.